10T with Walter Lewin. What is it? 45.9 plus or minus 0.2, period is 4.59 plus or minus 0.02. I told you, physics works. If I have a tennis ball in my hand, and I drop the tennis ball from a certain height, give it no speed, and it will bounce back, then it can never bounce higher than where it started from. If it did, then we physicists would say that is a gross violation of the conservation of energy, and that is the holiest of all laws in physics. It cannot go higher. Suppose the object has a mass m and is a distance h from the floor. Here's the floor, here's the object, h. We associate with the position of that object an energy that has a name. We call that potential energy. And that potential energy is mgh. You already know what g is. Well, h is this distance in meters. So when the object is here on the floor, h is 0. So there is no potential energy. As the object goes down, it picks up speed. And we associate with speed energy, which we call kinetic energy. And the kinetic energy of an object with mass m is 1/2 mv squared. M is the mass, and v is the speed of that object. If the object goes down and it hits the floor, then the potential energy is 0, and all that energy is now converted to kinetic energy. Because energy, we believe, is conserved. Now when it hits the floor, some of that kinetic energy may be converted into heat because of the compression. If it were a tennis ball, that would certainly happen. So in other words, when it bounces back, the total energy is no longer the full mgh, but is a little less, and so it won't bound as high. But there is no way that it could come up higher than h. Suppose it could come after one bounce up here. Well, that would solve the world energy problem. Because you simply sit down and you watch the ball game, and there goes the ball higher, and the second one, it goes again higher. If it goes the first time higher, it will do that the second time. And so after an hour, that thing is about a few thousand meters in the sky, and when it comes down on the floor, it has an enormous speed, great amount of kinetic energy, and so you got energy out of nothing. But there is no such thing in physics as a free lunch, so that's not going to happen. So the object can never go any higher than h. And with a tennis ball, there is also what we call the dissipation of heat when it hits the floor. Now, the situation is difficult with a pendulum, because a pendulum doesn't hit the floor, and so there is no heat loss because it doesn't hit the floor. So if you bring a pendulum at a certain distance above the ground, like this, and you let it swing, when it comes back here, it is almost exactly at that same height. Cannot be higher. That would be a violation of the conservation of energy.